Hey everyone, and welcome. Today we're diving into a really cool AI breakthrough called ERL-Re2. It's a totally new way to train AI that helps them learn like a super coordinated team. And it does this by finally getting two very different training styles to play nice together.
So to get our heads around this, let's use an analogy. Picture you're training a whole team of robot soccer players. Now, would you really make every single robot learn the physics of a rolling ball from scratch, all on its own? Or would it be way smarter if they all shared that basic knowledge and then could focus their energy on their unique jobs, like being a striker or a goalie?
And that right there is the exact challenge AI researchers have been wrestling with. How do we get individual AI agents to learn better together without wasting a ton of time and resources relearning the same basic stuff? This is the huge problem that this new method, ERL-Re2, was built to solve.
Okay, so to really get what makes this so special, we first have to talk about the two big players, the two titans of AI training that have been around for years, reinforcement learning and evolutionary algorithms. First up, you've got reinforcement learning, or RL for short. The best way to think about this one is as the meticulous coach. It focuses on just one agent at a time, giving it really precise step-by-step feedback to get better. That's what we mean when we say it's gradient-based. It's super efficient with data, but it can also be a bit unstable, and it's not very good at thinking outside the box and exploring new strategies.
And on the other side of the ring, we have evolutionary algorithms, or EA. This is the creative scout. Instead of coaching one agent, it basically throws a whole army of different strategies at a problem just to see what works. It's what we call gradient-free, because it doesn't need that precise feedback. It's kind of like natural selection. The best ideas survive and get combined. Now, this is amazing for exploration, and it's super stable, but man, is it slow. It just burns through data like you wouldn't believe.
So you can kind of see how these two are like perfect opposites, right? RL is really efficient, but a terrible explorer. EA is a fantastic explorer, but it's incredibly inefficient. The next logical step seems pretty obvious then. Just combine them, right?
Well, yeah, you'd think so, but it turns out it's not that simple. People have tried for years, and just mashing these two methods together created a pretty awkward team-up that had some really big problems.
These older hybrid models had two massive drawbacks. First, the learning was just super inefficient. Every single agent was still learning all the common knowledge on its own. It's our robot soccer team all over again, with every player relearning ball physics. Just a colossal waste of time. Second, the evolution was super unstable. When you try to swap little bits of an AI's brain, its network parameters, between these really complex agents, you often just break them. The whole thing crashes.
And this is where ERL-Re2 just completely changes the game with a really, really brilliant solution. The researchers came up with something they call the shared playbook.
The whole thing hinges on this core idea they call two-scale representation. And honestly, this is the secret sauce that makes the whole thing work. So here's how it works. Instead of every agent having its own complicated, separate brain, they split the intelligence into two parts. First, there's a shared state representation. This is one big, powerful neural network that all the agents share. It's their collective understanding of the world, the team's shared playbook. Then each agent has its own individual policy, which is way, way simpler. It only defines its specific actions. So think of it as their specific position on the field. All the hard work of understanding the game is done just once, by the whole team together. Then each player only has to focus on its simple, unique job. It's brilliant.
What's so cool is that this new structure doesn't just make learning faster. It actually changes the entire way these agents evolve. It's all about evolving smarter, not just harder.
The paper puts it perfectly. It says the old methods guaranteed no semantic level of evolution. And that's really just a fancy way of saying that swapping random bits of code was, just random. It had no real meaning, no connection to what the agent was actually doing, which is why everything kept breaking.
But with ERL2, you get what they call behavior-level evolution. Here's how that works. First, because those individual policies are so simple, you can actually isolate specific behaviors, like kicking or defending. Then, and this is the key, you can cross over entire behaviors between agents, not just random junk code. It's like telling one robot, hey, copy that other robot's awesome defending strategy. And finally, you can mutate with purpose. You can tweak one specific action without accidentally breaking all the others. It just makes the whole process of evolution way more stable and so much more effective.
Oh, and as a little bonus, this new structure also lets them figure out how well an agent is doing much, much faster. It's a technique with a long name, Policy Extended Value Function Approximator, but we don't need to get into the weeds. Just know that it gives the whole system another huge boost in efficiency. Okay, so the theory is awesome, right? But the big question is, does it actually work in practice? Let's take a look at the results, because this is where it gets really exciting. And wow, the proof is definitely in the performance. They tested this on a super complex task called humanoid, which is basically controlling a simulated two-legged robot. And the results are just crystal clear. The previous best hybrid method got a score of about 4,000. Your standard reinforcement learning got to about 5,000. But ERL-Re2? It just blows them both away with a score around 5,500. I mean, that is a huge leap forward.
And it's not just about the final score. It's about how fast it gets there. On some of the tasks, like one called Swimmer, ERL-R2 was up to 5 times faster. A 5x improvement in learning speed. That is a ridiculous speed-up. All right, so let's just recap the key achievements here because they're pretty incredible. ERL-Re2 consistently outperformed all the advanced methods across a bunch of different tasks. It set new state-of-the-art performance records, and get this, it was the first hybrid method to ever beat a pure evolutionary algorithm on the swimmer task, which has always been EA's home turf. It really did it. It finally merged the best of the meticulous coach with the best of the creative scout.
So, what's the big takeaway from all this? Well, by creating this shared playbook, ERL-Re2 has really unlocked a new level of efficient, collaborative learning for AI. It's a true game changer, and it leaves us with this one awesome question. Now that we can teach AI to genuinely learn like a team, what complex, real-world challenge should we point them at next?